Okay, so I'm going to try to help you with your word problems. This is, I guess, in this book, section 7 or 6-7. So here are some examples. Hopefully they'll help you. The length of a rectangle is 5 centimeters less than 7 times the width. Oh my gosh, I'm overwhelmed. Usually when you read a word problem, you're overwhelmed. Completely normal. So then maybe if you can draw a picture, you know, sometimes we can draw a picture, sometimes you can draw a rectangle or a triangle. If you can't draw a picture, maybe you can do something else. But the thing I teach in class is you always let X be. Always let X be. And then when it comes to measurement problems, usually the best thing to let X be is the last word, and the first sentence is kind of a key because everything else is based on that. So in this case, we're going to let X be the width because it's the last word in the first sentence. Width. Then you should, I'm going to advise you to fill out this thing on the right first before you ever fiddle with numbers. So you're going to say, what else do I need? Okay, I have my width and it's X, and maybe I also need my length, and this will help you. So then you can say, what is length in terms of X? Because the second step in word problem solving is the first step is assigning a variable to an unknown, meaning let X be. The second step is to express all the other unknowns in terms of that variable. A lot of students want to go straight to step 3, which is writing an equation. Please don't do that. You need to do this first. It's a process. It takes time. People don't have patience. You need to get some patience. Okay, the length is 5 centimeters less than 7 times the width. So 5 centimeters less than 7 times the width. You said the width is X, you see? So this will work, 5 less than 7 times the width. Now you know your width and length in terms of X. And just if you want the picture, there it is. And then you can deal with this. Sometimes if it's a triangle, you use a different formula than you do for a rectangle. But what is the rectangle formula? Area is length times width. Everybody agrees with that. I could write that as width times length equals area, because I maybe want it to look like this. And then I'm going to replace width with X. I'm going to replace the L, the length, with 7X minus 5 equals the area is 18. Don't put squares, don't put anything else in here like that. Then you're going to solve this equation. Well, this turns into 7x squared minus 5x equals 18. Quadratic equation, how do you solve those? You learned this in the previous chapter. So I'm not going to do a lot of explaining, I think, or maybe I am. Okay, it's a trinomial. How do you attack a trinomial? Leading coefficient not 1, so we're going to go over the top, split the middle term, because most of us are going to struggle trying to go straight into something times something. So we're going to keep the first one, keep the last one. And then over here, maybe, we're going to say, hey, what's my product? And I need a calculator, right? 7 times 18. Just to make sure I'm not doing this wrong, we're allowed a calculator. It's a negative 126. My sum is a negative 5. If you're struggling with this right now reinforces and it helps you learn factoring if you had trouble before. So now you need 2 things that you multiply, and then I told my students, try a 9. This is not a super easy one as far as figuring it out. What numbers? Which one has to be negative for that to be a negative 5, then negative 14? Now I'm going to put, these are the 2 numbers. When you multiply them, you get negative 5. When you add them, you get negative 5. When you multiply them, you get negative 126. Don't get up at 4:30 in the morning and try to make a video at 1. It doesn't work. So anyway, negative 14x. I'm going to put the 14 close to the 7 so I have something in common, plus 9x. And just one more time, this negative 14 and that 9 make the original negative 5, so I changed nothing. Now I have 4 terms, I double bubble. Factoring by grouping, double bubble. First bubble has a 7x in common, 7x times x, 7x squared true, 7x times negative 2, negative 14x true. Bring down that sign, plus 9 times x, 9 times negative 2. Now this is a common binomial factor. I pull that forward. I put my leftovers. And then I have equals to 0. I was a little lazy in between and didn't write equals to 0. You should keep that as an equation. Now I solve each one of those. X minus 2 is 0, so x equals 2. 7x plus 9 equals 0, so 7x equals negative 9, and x equals negative 9/7. Now I just want to talk about something. We have to let x be something, and then we only have one option for x usually. So in this case, you have to decide which one of them is x. You know, is it 2 or is it negative 9/7? Oops, maybe I shouldn't touch this. And you have to decide. If you're dealing with a measurement, you're going to have to throw anything negative in the trash. So go ahead and throw it in the trash and say, no, it can't be negative. Just remember that it's not always the negative you throw away. But if you're dealing with a measurement, you have to say that's impossible. Then you say x is 2, and you come back to the top and you say equals 2. And then you say, well, if x is 2, then if you plug it into this one, 7 times 2 is 14 minus 5, so then the length is 9. You need to label this appropriately, meaning in this case, we're dealing with the square centimeter if it's an area. So we're dealing with the centimeter to the first power if you have just linear. And then we check our answer in the original wording. Think about it. If you have 2 centimeter times 9 centimeter makes 18 centimeter square or 18 square centimeters, so it checks. So that's the first one. I don't want to do all of these as far as every single one because I have 6 of them. They could take forever. So I just want to, on this one here, I'm just going to mention the length is based on the height. Maybe you should let x be the height, right? And then you need to use a different formula. A equals a half BH if you're talking about area of a triangle. It's the base times height divided by 2, or half times base times height. Okay, this one here. Probably I'm not going to do the whole thing. I'm mainly trying to teach you all how to set these up so that, you know, after that, the math shouldn't be a huge issue. Oh, where's my pen? So let x be. I see a bunch of words, I'm overwhelmed. Let x be. And then last word, first sentence. Maybe I should, I know x is going to be a leg, you know, so people say, let x be a leg. Okay, good. But we have 3 legs, so we need to be more specific. So let x be the short leg. And then let's maybe draw a little sketch of a triangle. It says a right triangle, so wait, why don't we draw a little sketch? And let x be this guy. And then we have a hypotenuse is the longest, and then we have the medium leg down here. So let's call it medium leg. The wording on these sometimes can be a little bit confusing. A hypotenuse is always the longest leg, right? So you always want to let x be, if you're talking about a measurement, the last word in the first sentence usually, I don't want to say always, but it's the thing everything else is based on. So one leg is based on the shorter leg. It's longer, 7 millimeter longer than the shorter leg. The hypotenuse is 14 millimeter longer than the shorter leg. Maybe you should let x be the shorter leg. Then we say, well, this is what I want you to focus on right here. I need for you to think about what goes here before. So this here is important that you write that first. That way you now know, oh, what else am I looking for? Then you have to write these things in terms of x. Any other unknowns in terms of x. So one leg is 7 millimeter longer than the shorter leg. So 7 longer than the shorter leg is x. And then the hypotenuse is 14 millimeter longer than the shorter leg. 14 millimeter longer than the shorter leg. Okay, so I had people in class do this and they can't come up with this stuff. you have to brainstorm just a little bit and give yourself a little time, but focus. You always ask, what do I have? What do I need? What are we looking for? And then it says here, represent the lengths of the sides of the triangle in terms of x. So all you have to do is what I just did. That's all it wants, okay? It doesn't want you to solve for x right now. It wants you to do nothing else. Now we're dealing with integers. Integers can be interesting. When it comes to integer problems, you always let x be the first. And I want to write it with a 1, but then people think x is 1. First equals first, meaning the first in line, not the first, not number 1. It depends on where you're starting your list. Anyway, and then you say, well, I need 3 integers total. Excuse me, my office is ice cold. It's like 20 degrees in here. Now it feels like it's like 60 degrees in here. Okay, so you say x, let x be the first, and then you say, what else do I need? Oh, I also need the second, and I also need the third. Gosh, I hope I'm recording because I don't want to have to do this again, do I? Okay, we are. I think we are. So whenever you have an integer problem, you let x be the first integer no matter what. And then you do a little sketch. And people get so confused here. And I'm like, let's sketch the number line. Let's look here for a second. I'm looking for 3 consecutive even integers. And this part here is important. They're consecutive and even. Okay, integers are the things on the number line. So I ask you, stay away from the 0 right now. Let's just make up something. If I told you, hey, come up with an even integer, any number you want, I'm just going to use 86 now. 86 is an even integer, you believe it? Yes. What would be the next one that's an even integer? And you say on the number line, that would be the 88 and the 90. And right? And then I would say, okay, if x is the first one, and I'm saying if, I'm not saying x is 86 because people take me literal and then they say x must be 86. It's not. I'm saying if x is 86, then what is this guy in terms of x? And you just look at the 88 and look at how it relates to the 86. Is it not 2 bigger? Isn't this the x plus the 2? And isn't this 90? How much bigger than x is it? It's x and 4 bigger. You see? So when you have consecutive even integers, you always have the first one is x, the second one is x plus 2, and the third one is x plus 4. Then usually right here, I also like to talk about the consecutive odds because people get really confused. What if I said consecutive odd? And then they look at this and say, oh, okay, so let's say if there's a 91. And then the next one, if it's consecutive, meaning one after the other, and it's odd, it'd have to be a 93, and then this guy would have to be a 95. If this is x, what is he in relation to x? He is x plus 2. What is this one? He is, how much bigger than 91 is 95? 4. So I just want you to remember this. People say x plus 1 and x plus 3 on the odds. I'm like, no, the distance between the odd numbers is still 2, isn't it? When you have consecutive numbers, the distance between them is 2. So anyway, it doesn't change that fact. Now let's look at another scenario because you're going to have several. What if it just said consecutive? Not odd, not even, just consecutive. So you sketch a number line and you come up with any numbers you want. What if you had 100? What's the next one? 101? What's the next one? 102, if you're looking at consecutive numbers, not even, not odd, just consecutive numbers. If x is this guy, what is he? X plus 1. What is he? X plus 2. I'm just trying to show you this so that later you can do all these problems, not just one. So consecutive even, this is what happens over here on the left. So I'm going back to my original problem. So So this here are steps 1 and 2 if you were to read your steps on how to solve these type of problems. It's assign a variable and then the other unknowns in terms of that variable. Then you have to translate. So step 3 is the equation, you know, steps 1 and 2. Step 3 is the equation. So this is 1 and 2, 3 is the equation. Now you have to write an equation. You need to use the wording and you need to translate. You did this in pre-algebra, if you had pre-algebra. Okay, the sum is what? How about a plus? Of the second and third. So you go in here and you pick out your second. Hey, the second guy, second was x plus 2, wasn't it? And the third, and I'm only going to do this once where I completely write this down like this. So now I have the sum of the second and third of 3 consecutive integers is means equals 4 less than, this is the 4 less than 3 times the first. 3 times the first is x. And now I have an equation. Okay. Why did I put 4 less than in the end? Because you can't say 4 minus because there's no commutative property. So I hang it at the end. Like you saying, I have $4 less than 100. You don't have 4 minus 100. You have 100 minus 4. So watch this. Now what do we do? And then people stare at me and they don't know what to do. I'm like, solve this equation, right? X plus x is 2x. They made it x squared today. I'm like, what's going on? We're having a moment. 2 plus 4 is 6. Then I'm going to keep my x's positive. You can do this however you want, as long as it's legal, I always say. If I put my x's on the right, I'm going to end up putting my constants on the left, so I get 10 equals x, or x equals 10. Then I look back at the original. I need an eraser. Step 4 was solve. Step 5 is check it. So I need my pen back. So it's a word problem. So if you took this in the classroom, I would say you have to come up here and say 10. And you have to come up here and say, well, if x is 10, then 10 plus 2 is 12. And if x is 10, then 10 plus 4 is 14. Excuse me. This is so thrilling. I do this all day long, so it gets a little old, to be honest. It's hard to fake look enthusiastic on these word problems. Anyway, this is a word problem. It starts in words and should end in words. So your final answer really should be this whole thing here, not just 10. It's in school today, x is 10, circled, end of story, you know. So you need to remember that you're asked find the 3 integers. If you don't like doing this, where you set it up in the beginning and then give the answer, you would have to say the first integer is 10, the second is 12, the third is 14. Or you say, well, I'm just going to take this online so I don't actually have to write it out the way she would like it. Okay, clear. We're getting there. So here's a problem. It's another integer problem. So what you do when you see an integer problem is you're going to say let x be always the first integer. And then you say, what else do I need? In this case, I need second and third. And then I look at what are they in terms of x. So then I'm going to say, please sketch yourself a little number line. And these are supposedly negative consecutive integers. So when people see that negative, they want to make it like a negative x. Folks, you can actually do this, but it's going to make everything so much more dangerous. Let's look at this and keep it simple, if we can. Give me a negative number on the number line far away from 0. So how about a negative 35? I'm just making that up. And then what would be the next one? They're negative consecutive integers. So 0 is over here somewhere. So then the next one would be a negative 34. I have folks in my online class on ground right now that are struggling with this. If you don't know where something is on the number line, you have a problem you need to fix. Like, it's urgent. So negative 35, negative 34, negative 33, et cetera, until it gets to 0, and then it's 1, 2, 3 again. You know, basic number line. Okay, those are negative consecutive integers. If you let x be the first one, not this guy here, but this guy, leftmost, you can let x be the leftmost. What is this guy in terms of x? You see? And if you paid attention earlier, you would say, oh, it's x, but it's 1 bigger. And this guy, he's 2 bigger than x. So, and then you keep these things positive. You can make these negative. I don't want to deal with that right now because it makes the math more complicated. It's completely fun for me to do something different, but I'm trying to keep this basic for the group. Okay, the product of the first and third is 59 more than 4 times a second. Oh my gosh, what do I do? Well, I said let x be, and then I labeled these, and now I can translate the product. So everybody in class is doing a plus. How about a product? Yes? Product of the first. The first is what? Oh, it's right there. X. And third. Third is right there. And let's use a parentheses so you don't forget to distribute because you're multiplying everything. Is means equals. 59 more. I'm going to hang it at the end. You could say 59 plus, in this case it'll work. Then 4 times the second. This guy is the second, x plus 1. And now you've set it up to where you can do this, no problem. Oh, I'm having such a hard time with the totals. So what's going to happen here is you're going to get an x squared plus 2x, equals 4x plus 4 plus 59. You get x squared minus 2x minus 63 equals 0. I'm taking some shortcuts, but I combined these two into a 63, then I subtract them over. I subtracted the 4x over, and I end up with a negative 2x, so I took some shortcuts. Then you say, okay, now to solve this quadratic, I have to factor it. I need a times b equals 0. X, negative 9, positive 7, because you did your thing, negative 63, negative 2, negative 9, positive 7. And then you solve each one. X minus 9 is 0, x is 9. X plus 7 equals 0, x equals negative 7. So we get here in class, and they're so used to throwing away the negatives that they threw this in the trash. And I have to ask, let's go back to the original and look at what the original said. The original said they have to be negative numbers. So wouldn't you take that 9 and throw it in the trash and say x can't be 9 because it has to be a negative number? So in this case, you're going to choose x as negative 7. So you come up here and say the first integer is negative 7. And then the next one is negative 7 plus 1, which is negative 6. The next one is negative 7 plus 2, which is negative 5. These are your final answers. And then I probably should have checked the previous one in the original wording, and I didn't. But let's just do this one. Let's check this one. You know, let's do that in green. Let's check it. Does it check in the original wording? You have the product of the first and third. The first and third is 59 more than 4 times the second. So 35 is negative 24 plus 59, question mark. You know, and you have a calculator, so you're going to see, hey, that checks. Okay, clear all drawings next. Oops, need a mouse. We're getting there. Oh, this is the last one. That's good news. Okay, this one here, there is one in the homework like this. So this could throw you for a loop. The sum of two integers is 27. So it's integers, so we're going to let x be the first, okay? And then you should say, well, I also need a second. And this is really kind of, this one is a little weird, okay? Because they're not consecutive, they're not consecutive even, consecutive odds. You don't know how they are related, except you get a little hint here in the beginning. So I want you to ask, hey, if I told you the first plus the second equal 27, right? Because that is listed, or this is stated right here, the sum of the two integers is 27. So you could come up with, what we're trying to find here is what is the other one in terms of x. So the x plus the blank equals 27. Do you see it? So you should be able to come up with this, that then the blank is 27 minus the x, because you're isolating the blank, right? So you're subtracting x from both sides. So 27 minus x is the second integer. And now you translate all of this. Where is a regular black pen? I cannot find a regular black pen. But now you use the fact that the sum of their squares, x squared and 27 minus x squared equals, right, is 369. And then you solve this thing. What goes wrong with this a lot is a ton of my students did the following. I'm going to do this now and I'm going to erase it, so please don't write this down. They say 27 squared is 729, and then you have a negative or a positive x squared. And then they had a problem. And I pointed out that a minus b quantity squared is not a squared minus b squared. And it's not a squared plus b squared, for sure. So this is impossible. What happened? They didn't remember the formula, or they didn't FOIL. Do you see how you can always FOIL? Or you can use the formula. A minus b quantity squared is a squared minus 2ab plus b squared. This is from back, this is from back when? Chapter 5, when you were multiplying binomials, and this happened to be a binomial squared. Okay, so here, if this is a and this is b, this is going to be a squared, which is 729, minus 2ab from the formula, a times b and double it, plus b squared. This is the 2ab. Not worrying about signs. So if you don't like this, if this makes you uncomfortable, it's completely normal that it would, then you just FOIL this out, 27 minus x, 27 minus x, and you're going to get the same thing. Okay, now I'm going to combine like terms. X squared plus x squared is not x to the fourth. X squared plus x squared is 2x squared. Minus 54x, I'm going to go ahead and put this in standard form. So I'm going to subtract 369 from this side and subtract 369 from this side. And my trusty folks told me this was a positive 360. And then you pull the 2, because when I say factor, you say greatest common factor always. And that turned it into a simple trinomial here, where it simply opens with an x squared. So we're going to open, close, open, close. We're going to say I have a 180, I have a negative 27, and then I'll shortcut it for you, 12 and 15, and negative, make that happen. Where you add them together, you get a negative 27. And you multiply them, you get a positive 180. Then you solve this thing, set each one equal to 0, 2 equals 0, never. So you get x is 12 or x is 15. And then really, are you going to throw one in the trash? Let's look at it. if you say x is 12, then 27 minus 12 is 15. If you say x is 15, then you're going to say 27 minus 15 is 12. So in this specific case, it does not matter which one's first and which one's second, because they weren't in order either. So I hope this helped, Sam. I know that word problems are pretty tough for people, so I'm hoping this helped. I'm hoping you use the resource. Thank you. Bye.